doing example 3, just example 3 from section 3.2. All right, so I've got the piecewise function written here, and I've got an empty graph set up. So this is again, it's a piecewise function. Part A is to graph it. So whenever we're graphing piecewise functions, I suggest that we begin at the so-called breaking x value or values. In this case, the function changes at 2 and then again at 4. So we'll focus in on those two places. It says that if x is less than 2, the function is defined to just be constantly 1. So here's x equals 2. Remember, this is an x value. If x is less than 2, the output value is constantly 1. And I've got a strictly less than there, so I'm going to put an open circle indicating that it's not defined to be 1 at that place, just for every value of x to the left of 2, less than 2. Okay, then the second part of the function is, and the way that you can read this, where is the x? It's between 2 and 4. It's less than or equal to 4, and it's greater than or equal to 2, so that's between 2 and 4. Inclusive on both of them, meaning we're going to put filled in circles there. All right, so if I plug 2 now into here, I'm going to get 2 plus 3, that's 5. So if I'm at 2, the output is 5. I'll try to put that at exactly the right place, about there. Again, filled in circle because that's less than or equal to, or actually if you read it left to right, x is greater than or equal to 2. And then if I plug in the other end, 4, if I put 4 into here, 4 plus 3 gets me 7. So when I'm at 4, I'll be at 7, which is maybe right about here, if I'm looking at this right. And again, filled in circle because this is also equal to. Now, what is this function? It's linear. So basically, I have 2 points. That's enough to define this linear function. So all I have to do is just connect them with a line. Okay, and then finally, if x is greater than 4, the output is 7. But notice I already have an output of 7 right there. I'm not going to put an open circle around that. I'm just going to say, all right, I'm going to continue. Constantly 7, that means a horizontal line at y equals 7. So that's what the function looks like. For part B, it says find all values of x where the function is discontinuous. So if we just go on our intuitive definition of what it means to be continuous, if I'm graphing this function, there's only one place that I actually have to pick up the marker to finish drawing it. That's right here at x equals 2. Here, when I continue, I never have to pick up the marker, right? So there's no discontinuities other than at this place where I had to jump. That's called a jump discontinuity, by the way. So for part B, we've got discontinuity at, discontinuity at x equals 2. Remember that when we're referring to discontinuities on functions, we always want to refer to the x value where that discontinuity occurs. Okay, so then part C, find the limit from the left and from the right at any values of x in part B. Well, there's only one place that we had a discontinuity. So what we need to do now is find the limit. 2 things. We want to find the limit as x approaches 2 from the left for this function, and we want to find the limit as x approaches 2 from the right for this function. So we can do that by looking at the graph. So again, as I approach 2 from the left, notice that if I pick any of these values like 1, 1 or 1.5, 1.9, the output is always 1. So it seems that as I approach 2, the output approaches 1, even though it's just always 1. So the limit there is 1. If I start plugging in numbers on the other side, like maybe 2.5, this one I'll actually draw. If I put 2.5 in here, the way that I find the output is I just go up until I hit the graph, go over here. I get that output, something like between 5 and 6. If I get a little closer, see what the output does. Well, it's a little bit lower than the other one, right? So the closer that I get to 2, it seems that these outputs seem to be getting closer to that number 5. Okay, so in that case, the limit is 5. So the limit from the left and the limit from the right are not the same. Mathematically speaking, that's why there's a discontinuity there. The limit from the right and the left are not the same. So really, we're not asked to do this, but since this is the case, these 2 limits are different. the limit, if I take the plus or the minus off of it, we could say that limit doesn't exist. And that is the reason that we have a discontinuity at x equals 2.